Make clear it is explanatory only and not a repair guide. Explain the video goal and say this will cover how common air conditioning systems work, their main parts, the basic refrigeration cycle, different system types, efficiency metrics, common causes of poor performance, maintenance and safety, and environmental considerations. Give a simple definition of air conditioning as the process of controlling indoor air temperature, humidity, and quality for comfort or process needs. Describe the basic refrigeration cycle in plain terms. Refrigerant is compressed into a hot high-pressure gas by the compressor, then it flows through the condenser where it gives off heat and becomes a liquid. The liquid passes through an expansion device where pressure and temperature drop. In the evaporator, the cold low-pressure refrigerant absorbs heat from indoor air and evaporates back into a gas, which returns to the compressor to repeat the cycle. Introduce the main components in simple language: compressor, condenser coil and fan, expansion valve or capillary tube, evaporator coil and blower, refrigerant lines, filter dryer, and thermostat or controls. Explain how air is moved and conditioned. Indoor air is pulled by a blower across the evaporator coil where it is cooled and dehumidified, then supplied back into the space through ducts or directly from the unit. Outdoor air or exhaust heat is expelled at the condenser. Describe common system families without construction detail: window and portable units for small spaces, split systems with indoor and outdoor sections, packaged rooftop units and central systems for homes and buildings, heat pumps that can reverse the cycle for heating, and VRF systems used in large commercial installations. Explain roles of controls and sensors. Thermostats set desired temperature. Thermostats and pressure and temperature sensors control compressor cycling and safety cutouts, and modern smart controls add scheduling, zoning, and remote monitoring. Cover basic performance metrics simply. SEER and AIR measures seasonal and instant efficiency for cooling. COP measures coefficient of performance for heating or cooling, and higher ratings mean better energy use for the same cooling output. Talk about sizing and load conceptually. Systems are selected based on cooling load, which depends on square footage, insulation, windows, occupancy, equipment heat, and solar gain. Undersized units run continuously and oversized units short cycle, so correct sizing is important. Outline simple operational trade-offs and common causes of poor performance. Dirty or clogged filters and coils reduce airflow and heat transfer. Low refrigerant due to leaks reduces capacity. Poor airflow from blocked vents or fans, incorrect thermostat settings, and electrical or control faults. Emphasize that refrigerant work and electrical repairs must be handled by certified technicians. Describe routine maintenance at a high level: regular filter changes, keeping outdoor condenser clear of debris, periodic coil cleaning and drain pan checks, checking airflow, and professional seasonal inspections. Do not provide step-by-step service instructions for refrigerant or electrical systems. Explain safety and regulation points. Refrigerants are regulated for environmental impact and must be handled only by certified technicians. Electrical work carries shock and fire risk, and units should be serviced according to manufacturer and local regulation. Discuss environmental and efficiency considerations. Modern low GWP refrigerants, improving insulation and passive cooling to reduce load, the benefits of heat pumps for heating and cooling, and energy-saving tips like programmable thermostats and correct sizing. Describe how engineers test and commission systems conceptually: airflow and temperature measurements, refrigerant charge verification, electrical checks, sensor calibration, and performance testing under simulated loads. Suggest safe learning paths and resources: HVAC courses, manufacturer training, accredited certification programs for technicians, textbooks on thermodynamics and HVAC fundamentals, and reputable online technical resources. Summarize the key ideas. Air conditioning removes heat and moisture from indoor air using a refrigeration cycle and airflow. Different system types suit different spaces. Efficiency and correct sizing matter, and safety and regulatory limits mean servicing and refrigerant work must be left to professionals. Visual suggestions for the video input. Show animated diagrams of the refrigeration cycle with labeled compressor, condenser, expansion device, and evaporator. Show cutaway views of a window unit, split indoor and outdoor sections, and a heat pump reversing flow show airflow animations across coils and through ducts, and filters show overlays of SEER, air, and COP definitions and simple comparisons. Show maintenance visuals like changing filters, clearing debris from the condenser, and a technician performing professional inspection, no DIY refrigerant work. End with call to action to learn HVAC fundamentals through courses and to hire certified technicians for installation and service. Use this full script as the video input for Pictory.ai to generate an educational explainer about how air conditioning works.